All right, so welcome everyone back for the final keynote talk of the IoT Day, or as we should call it, AI plus IoT Day. And our final speaker is Dr. Landon Cox, who is a senior principal researcher at Microsoft Research Redmond. He most recently worked with Azure Programmable Connectivity and helped deploy the exposure notification in the state of Washington. Landon was honored as a ACM Distinguished Member for his work on privacy in mobile computing and operating systems, and received a SIGOPS Hall of Fame award for his OSDI 2010 paper. Prior to joining Microsoft, he was a tenured faculty at Duke University. But of course, all of us know him as the editor-in-chief of the Get Mobile magazine that comes to all of our doorsteps every quarter. Today, Landon will talk about understanding privacy for physical AI, or living with C-3PO and R2-D2. Over to you, Landon.
Thank you. Thanks for the introduction. So I just want to start by saying that this is going to be a very different talk than the one that Lynn gave. So this is a results-free zone. This is more of a digestion of kind of what I and others around me have been thinking about physical AI. And so I spent most of the last 4 years with Victor and Azure working on telcos, trying to bring telcos onto the cloud. And since we've come back to MSR, it's really that time when we've been thinking about AI, and specifically thinking about AI in physical spaces. So this talk is kind of a summary of some of those conversations. And so I first want to acknowledge who I've been having those conversations with. So a bunch of people from this group, as well as Vaishnavi, Matul, and Javier. So a lot of what I'm going to talk about also comes from them, right? So I'm summarizing things that I've discussed with them. Okay? And this is really things we've talked about over the last 6 months. So I'm looking forward to your feedback on our thoughts. Okay, so I wanted to start by talking about where the business of AI is, not necessarily the tech, okay? And I could have come up with my own charts and trends and all that, but really, I wouldn't have done a better job than Mary Meeker. So she released her report on trends in AI about 3 weeks ago. And so I'm going to highlight some of the things that she reports, just to sort of set the stage, okay? So the first thing that I think we all know is that LLM use, AI use, has really exploded the last 3 years. So ChatGPT now has 800 million weekly users in just 3 years. That's pretty remarkable. And just to put that in context, that's 5 times the adoption rate of Google. So they reached 365 billion annual searches in 2 years. It took Google 11 years. So if we're all sort of feeling the pressure of this massive new technology, it's not all in our minds. It is actually being adopted at an unbelievable rate. And in addition to that, the cost of inference is declining rapidly. Okay? So it's not just that things are taking off, things are getting cheaper, which means they're going to continue to take off. Okay? So it took computer memory over a decade for its price to drop, as far as LLM inference dropped just in the last 2 years. Okay? So this stuff is becoming much more pervasive and much cheaper. I think we all can feel that. Okay, so where are we headed? So this is a graph that looks at sort of different kinds of technologies over time, and then you've got the enabling infrastructure on the bottom. And so the next biggest bubble there represents smartphones, the mobile internet, right? And so you see there are about 4 billion plus smartphones. Now, the next bubble is the predicted size of devices for the AI era, and this is tens of billions of devices. Now, this is something that Victor and I faced in AFO, where telcos were rolling out new networks, and they needed to recap the expense of rolling them out, but there are no new smartphones to really bring online. So what they were desperate for but didn't know how to do is to bring a new class of device onto the network. But there's a good chance that AI is the thing that is going to bring these new devices into existence. There's a reason for them to exist. And it's not going to be better networks, it's going to be better intelligence. Okay, so if you sort of peek into the small text here of this chart, they say it's smartphones, yeah, but it's also IoT devices, and it's also robotics. Okay, so this is where the future is. It's in these two things. Okay, so how are we doing now with those things? So you probably all know about Waymo. This is Google's taxi service, autonomous vehicle taxi service. It's now more popular than Lyft in San Francisco over the course of just a few years. So it's overtaken Lyft, and if you believe the trends, it's going to overtake Uber, and this is just in a very short period of time. So physical AI, even though it's just in its infancy, if you look at where it's going to take off really fast. Okay, another example of a deployed physical AI system is Tesla full self-driving. They've reported a 4 times increase in usage in a single year. So if you look at the shape of all of these graphs, they're all the same. It just starts out slow and then spikes. So you see this in every single AI graph of usage, okay? Now, taking a step back, I think it's worth thinking about how do we categorize different kinds of physical AI, and I found it useful to categorize them by single purpose, multi-purpose, and then general purpose. And beyond that, sort of dividing these different categories into the intelligence behind the AI plus the hardware that it embodies. Okay? So we can kind of look at different things that fit into these different categories. And if we start on the left with single-purpose devices, we've got things like personal assistants, Alexa, things like Roomba. They've been around a long time. You look at warehouse robots like Amazon is using. These things do one thing, and they do it well. When you start to get to multi-purpose, you maybe can put robo-taxis in there. You can put automated, autonomous farm equipment in that category. Maybe your wearables, like your Ray-Ban specs, are multi-purpose. And then you've got these other sort of more speculative kinds of robots like the Spot Dog and the Stretch. And if you kind of look at this, and then in the far end, you've got our sci-fi general purpose robots, R2-D2 and C-3PO, okay? And if you look at what's really deployed, it's actually still all the single purpose stuff, right? It's actually kind of hard to find many multi-purpose physical AI systems that are highly deployed. And this is in contrast to the LLM usage, which has already taken off. Okay, so physical AI really hasn't taken off. Okay? And then if you start to look at the intelligence behind these systems, it becomes a little bit apparent why that is, which is that the intelligences behind these systems, for the most part, are also single purpose. So you've got Whisper that can do speech to text. You've got Slam for navigation. You can do image segmentation. Emma is a very nice autonomous driving model from Google. And then you've got robotics models like Magma and OpenVLA. And they're more or less multi-purpose, but they're all still pretty limited. So the point of this is to show that, yes, things are taking off, but they're not really taking off in this domain yet. And I think that gives us a huge opportunity to sort of point the field in the right direction, okay? We have a long way to go before we get to general purpose physical AI, okay? The other thing, because I'm a privacy guy, I look at this and I'm like, you know what? There really isn't a privacy issue with any of this stuff, right? There's no privacy crisis for Roombas. Nobody cares. Or, I mean, Alexa people did some privacy work, but for the most part, it wasn't the end of the world. Even for self-driving cars, it's not really a privacy problem, okay? And so just to try to confirm that privacy really isn't in this world yet, I went back to the Meeker report and actually searched for privacy. Okay, so this is me searching in the report, and I got one page. So the Meeker report is 400 pages long. Privacy is mentioned once, and frankly, it's not even a real mention. It has something to do with Apple's private cloud, okay? So the current status of AI as deployed, privacy is not an issue, okay? So, I mean, that kind of gives me pause, but thinking about why that is, it makes sense. And the reason it makes sense is because the settings in which these physical AI systems are deployed, privacy is not a problem. So if you think about like Amazon warehouses or on the road or factories, we don't really care about privacy. And even in the home, the devices are so limited that you don't care, right? Nobody cares about the privacy implications of a Roomba, okay? But as you start to move into the world of general purpose robots, general purpose physical AI, and we think about deploying them in offices, and we think about deploying them in homes, then privacy becomes an issue, okay? So that's why I think it's worth thinking about, because this is where the puck is going. Okay, so the way that I'm going to structure the rest of this talk is to go through each category, single purpose, multi-purpose, and then general purpose, and just kind of do like a thought experiment of how do we think about privacy in each of these categories. Okay, so the first two, I'm going to do case studies of projects that we've discussed and some of the privacy solutions that we've come up with and sort of what the principles for those solutions might be. And then we'll talk about general purpose physical AI. Okay? So let's first talk about a single purpose application or use case, which is an always-on transcriber. Okay, so this is a simple device that you bring with you everywhere. It's always on, and it's always converting whatever speech it hears into text. Right? So this is like a life recorder that people have talked about for a very long time. Okay, so somebody comes along, there's a conversation, somebody says something, and it records it. Somebody else says something, and it also records it. Okay? So the privacy implication here is pretty clear because this device is indiscriminate. So if the other person says something that it doesn't want recorded, it's still going to record it. Right? So the thing that we came up with for this solution is let's simplify the device in the sense that it should guarantee it only records you. So it's going to do on-device diarization. It will only transcribe its owner's voice. Okay? So now, when this owner speaks, it's recording, but it doesn't record anybody else's voice. Okay? Now, capturing only one side of the conversation is super useful, but if you imagine that lots of people have these kinds of devices, then they can each record different sides of the conversation, and then at some point, they can take their private pieces of the conversation and stitch them together through some sort of secure protocol. Okay? So it's a single-use device. It's interacting with the physical environment, and it can still do something useful. Okay? So what are the key ideas? I think the key ideas here are, number one, the device has very limited capabilities with very easy to understand behavior. It's only going to record your voice ever. And then you add complexity through an out-of-band secure protocol, but the key thing here is that it's on-device intelligence. Okay? So it's a simple device, simple to understand, and simple enough that it can be run on the device itself. It also raises a bunch of challenges, right? So I think the biggest one is how do you convince somebody that this thing you're holding will only ever record your voice and it's safe to have on all the time? So that's an HCI problem that, frankly, I don't have an answer to. There's also this sort of more technical problem of how do you perform accurate diarization in a very small form factor. So we've been playing around with some of these, and the accuracy is hit or miss. Right? Then there's this question of how do we securely exchange these snippets of conversation to reconstruct the whole and integrate it with a permission system and all this kind of stuff. So we have an intern who's working on this thing. And I think the bigger question is, can these key ideas be generalized to other modalities like video and to other use cases? And we don't have a good answer there. Okay? So that's a single purpose use case. I'm going to talk about a multi-purpose use case. So here is a simple device that just detects sounds around the house. So this one is actually very near and dear to my heart. And it's because I am constantly in the kitchen doing something, and I want to know when, say, the water is done boiling. Okay, so I want a notification because I'm in some other part of the house, and I want to know when is the water boiling. But you can generalize this. You could say, well, I'm starting the laundry. I would like to know when the washing machine dings. Or I'm upstairs, let me know when somebody is knocking at the door, or baby monitor, let me know when the baby starts to stir. Okay? So simple sound event monitoring that sends me a notification when something happens. Okay? So multiple purposes. Your phone can actually do this. How many people knew that their phone could already do this? I didn't know my phone could do this until recently, but it can. It's under the accessibility settings. It will sit and tell you when certain sounds appear, and then it'll send you a notification. It's actually pretty impressive. Okay, the problem is that I want to keep my phone with me, right? I don't want to leave my phone down by the laundry. I don't want to leave my phone by the stove. I want to take it with me. So instead, what we would really like is some sort of separate device, some cheap separate device that we can leave around the house and move around the house and can just listen for these events and then send us notifications. Okay? So here the key idea, like before, is that this is a device with clear capabilities, simple capabilities. It only listens to some fixed set of events. This device is going to be inexpensive enough to leave around the house. So I think of this as an AirTag, right? So yeah, it's not something you throw away, but it's also not something you're going to be devastated if you lose. And there are enough of them that you can spread them around and move them around. They don't have to be single purpose, right? And just like before, on-device intelligence is critical. So if we're thinking about what sort of technical challenges are really important to support privacy, I think getting better on-device intelligence is paramount. So if that means quantization or other sorts of ways of getting models to run well on constrained hardware, I don't know. But I think on-device intelligence is emerging as clearly pretty important for privacy. Okay, so there are a bunch of other challenges we don't really know how to address. Just like the last one, how do you convince somebody that this little doohickey actually only does the thing that it's supposed to do? How do you do that in a very small and constrained form factor, like an AirTag, with severe battery constraints potentially? And then again, can we generalize this? Could you do something like this for video? Could you point a camera at these different things and ask it to watch for events that happen in a camera? Okay, so those were our thought exercises for single-purpose applications, multi-purpose use cases, and then we move on to general-purpose physical AI. And so looking back on this picture, I was thinking about whether Star Wars could offer any helpful hints here, right? This is sort of our North Star for what we want to create. And unfortunately, the thing that I realized pretty quickly is that there's actually no privacy in Star Wars. It's actually a pretty terrible lens through which to think about privacy, okay? But thankfully, there's another fictional universe that my wife loves. Does anybody know what this show is? Okay, so this is the show Downton Abbey. It's a British show. I love it, but it is really like my wife's favorite show. So what's it about? It's about an aging English manor where you've got a domestic staff help that actually runs the house, and then you've got an old aristocratic family that lives in the house. And a lot of the drama in the show is about keeping secrets. I mean, you see this in a lot of literature, where you've got this sort of upstairs, downstairs dynamic between the staff and the house, okay? So it occurred to me that this is actually a great lens through which to think about general purpose physical AI, right? So I went back and I did some research on how did people in these households ensure privacy. And I think that some principles are revealed for when we actually have general purpose physical AI in our homes, okay? So the first one is there really needs to be some sort of hierarchical trust system, right? So in the world of Downton Abbey, you have the butler Carson, who is in charge of everybody else, and the family trusts him completely, but he is in charge of watching everybody else. And then you've got the head housekeeper, who is in charge of a team of housekeepers, but the head is trusted among everybody else. And so what you end up having is somebody who watches the watchers. And I think for physical AI, we are going to need physical AI to watch physical AI. I've thought about this a lot. I don't see how you can get around that. The second lesson from the world of Downton Abbey is I think you really have to regulate physical space. So this picture is of different rooms that the staff could and could not enter. And beyond just places that they could and could not go, the house itself had passages that were meant for the staff to walk, so that the staff and the people in the house never saw each other at all. And on top of that, they had separate living quarters. So the physical space was carved up between the staff and the people in the house. And I'm not saying that this would be practical or sensible when we have robots in say, apartments. But I do think you have to think about regulating access to physical space in a pretty serious way. Okay, the third principle was the need to regulate time. Okay, so this is a timetable, schedule, for different staff of where they could go and when. And so I think you will also need to regulate the hours of operation for any physical AI in these systems, right? So you need to be able to say, well, this AI will not be present at this time, maybe in this place. So a combination of temporal and physical regulation, I think, is really important. Okay, so what does all this lead to? I think it means we have to build an OS. I think that was always the conclusion that I was going to come to be honest. But I do think that we need some kind of distributed operating system for physical AI with its own actuators, its own sensors, and its own intelligence. I don't think you can have something that is software itself. I think you need something that interacts with the physical world just like the things that it's trying to control interact with the physical world. And the reason for this is that every operating system has to have the last move, right? It always needs to be able to take away memory. It always needs to be able to take away, it always needs to be able to kill a process. And unless you have control over the physical environment, I don't see how that's possible if you have robots and other kinds of physical AIs. So one of the implications of this that's maybe, that surprised me, maybe it's crazy, you can tell me if you think it's crazy, is that maybe mobility is just a privileged operation in this world, right? We don't allow robots to move on their own. They have to move around in little carts that we control, right? So we can actually limit and know exactly how AIs are moving through a space. This is probably not as surprising. Maybe there has to be a required kill switch. So anything that enters the house, we have to be able to immediately disable it in some way in case something goes wrong. Now, the mechanism by which you do that, I don't know. Maybe it's that you pull its power. I don't know what it is. But I think there have to be some kinds of restrictions on the physical properties of these AIs if we're actually going to bring them into privacy-sensitive spaces. Okay? Okay. So with that, I actually would like to open it up for discussion. I want to conclude by repeating that I think this is a really useful way to think about physical AI, dividing it into these categories of purposeness. So single purpose, which is simple, multi-purpose, a little bit more complex, and then the sci-fi droids of general purpose. And then I think it's also useful to think about some general principles for preserving privacy when we get all the way to general purpose physical AI. Those being hierarchical trust, controlling access to physical space, and controlling the hours of operation. So that's my talk, and I'm happy to answer any questions if you have them.
Right, let's thank our speaker. Feel free to queue up with questions. I'll start off with a question from my own. So you mentioned that we need some kind of privacy policy, kind of almost for physical AI. So what would that policy look like? Most of these policies have been implemented by big governments like EU or by the US government, like GDPR was a great success. So how would this policy be designed, and why would AI companies even agree to it, right? Like, because given the political world we live in, how do we see a pathway towards a policy for physical AI and also in general AI?
Yeah, so it's a great question. And this is why I think we need an operating system, because I think that's an example of where we do have policies and constraints on software that all run under some platform, right? And people sort of trust Windows, or they trust Mac OS, or they trust Linux. So I think we need something equivalent to that, rather than having the chaos of just a bunch of things running around your house. I think they have to run in some sort of platform that you trust. I don't know how you establish that trust. Maybe it's from a trusted vendor. I don't know, maybe there's some other mechanism by which you establish trust. But I think it has to come down to the people who own those spaces insisting that if a physical AI is brought into it, it has to be conformant with this platform, and as a result, regulated by whatever policies the owner has in mind. I think mobile is a decent starting point for this, where you grant apps permission to certain resources, just like you might grant physical AI access to certain places in the house or certain times of operation, and then it's up to the platform to enforce those policies.
All right, we can go to that.
Hi, Landon. Nice talk. You know, the privacy of IoT devices, especially the ones that have AI capabilities, near and dear to my heart. So I enjoyed listening to your thought process. There was one point that you mentioned about how can you convince someone that this is trustworthy, and you mentioned that this is kind of like an HCI-related problem.
Yeah.
I think there are two separate issues here. One is convincing non-savvy users, regular users. I agree. They're probably just, you need brand building, right? They need to trust the brand.
Yep.
So not a very technical problem.
Right.
But to get there, you probably first have to convince more savvy and technical people,
Yes.
right? And I feel like there are a lot of interesting, potentially technical problems there, right? I've been thinking
Absolutely.
about this problem. You obviously need probably open source, verifiable build, remote attestation, secure updates. There's a whole bunch of stuff that goes in there. So I was wondering if you've thought about that, and I find it to be a slightly difficult problem, but I wonder if you've thought about how that could be achieved.
I think you're right. I think I've probably drawn my experience with exposure notifications. So for those of you who have forgotten, that was the Bluetooth the new Bluetooth contract tracing software that Apple and Google rolled out to everybody's phones. And there was a lot of concern about whether it was going to, collect everybody's location at all times and then send it to the government. Because effectively that's what it does, but through some cryptographic magic, it doesn't actually do that. But it gives you the same functionality. And I was thinking, well, how do we convince everybody that this was going to be okay? And it was a lot of effort talking to policy people and government people who are not technical, but who trusted the local universities, and I think ultimately trusted Apple and Google. So those companies had built up trust. I think there was a little bit more skepticism outside the US, maybe with good reason. But yeah, it was all it was a very social process. In addition to having the technical details down pat, so that the crypto professor at UW could stand up and say, look, this is fine.
Yeah.
This behaves exactly how I would expect it to behave. And by the way, I was a participant in designing this. So yes, it's socializing, but it's also having people you trust stand up and say, this is good and correct and does what it says it does.
Yeah, thank you.
Hello, Landon. I'm a student from Chinese University of Hong Kong.
Hi.
And actually, I have a very similar question with just the dead speaker. I'm also concerned about the privacy issue. But my concern here is that I don't know whether you have ever thought about how do you define something is a privacy. Because just during my recent research, we find that there is a gap between the privacy for consumers or for the researchers, because sometimes the problem can be solved by some technical encryption or privacy protection methods, but it seems that it will not be easy to convince the consumer that it is privacy protected. And vice versa, maybe for the consumer, they don't care about that, but for the researcher, we need to protect it. So I don't know whether you have ever thought about the privacy issue involved here.
I have thought about it, and it's very hard.
Yeah.
Because especially for a non-technical, it's one thing to convince, I don't know, the program committee of S&P or Oakland or something that this is actually privacy preserving, but then going and talking to your 80-year-old dad that actually this isn't, sending information to the government in a way you don't want. That's a very tough, that's a tough nut to crack. And so, as I said to Ardalan, you have to sort of get people that are broadly trusted to say this is what it says it is. It can be hard. You may never achieve that. That's why I leave it as an open question. And I'm not necessarily sure that I know in this community alone we cannot achieve this. Like, this is something that requires much broader buy-in from people who are non-technical. Yeah.
So I don't know whether for the actual design, for the researcher, do you think it is necessary for us to make sure everything is privacy protected, so as the product is provided to the consumers,
I think the
even
important,
if it is not necessary?
I think the important thing for researchers is to just be transparent about what they have designed. If it does something, then and you can prove it, then beat your chest and say, yeah, it does this thing. And if it doesn't do that thing, then also be clear. Here's the limitation. Okay. I think that is honesty is probably the most important thing when you're trying to convince other people that something is worthy of their trust.
Okay, thank you.
Hi, just for everybody else, we do work together, and I do have access to Landon quite a bit more, but I hadn't heard this particular talk, so I have a question and a comment.
Yeah.
So many, many years ago, when location was starting to become mainstream, one of the things that came up with between legal lawyers and policymakers was that how do we keep location private? And so they came up with this whole thing that whenever you wanted to allow location, you had to sort of accept it or not accept it. But they all knew that nobody ever reads any of those things at all.
Yeah, absolutely.
Now, one of the questions that came up at that time, which is actually valid here as well, I did like your answer about the operating system being the one that can guard this. So I think that was very, very correct and accurate. But when you buy, in the physical AI world, when you have so many different devices that are being developed and you buy them, if you buy it from the same vendor, now on a device level you can create privacy. But if you want to do something more interesting and more meaningful, you might want to take different inputs from different places to do it.
Yep.
And that then compromises privacy in some sense. So.
Yep.
Some device may not tell where it is located to give you a sense of what it's looking at and where it is, but
Yes.
a bunch of devices whose location itself is known in some sense could lead to, if you did some
Yes.
analysis of that, you could come up with that. And the same is true for heterogeneity. When you buy devices from somebody else, and then there's another company that becomes the aggregator and can have the same
Yep.
problem. So
Yep.
then, in your world, the operating system can't solve this problem, right? So the policymakers will have to. So that goes on to the first question he asked, that you will have to have some sort of regulations there to prevent, all this information to flow. Is that not true?
Yeah, so first of all, we saw this in mobile apps, right? You would deny access to a resource in one app, but then allow another to access that resource, and then the one you gave the access to would just share it with the one you didn't give the access to, right? So collusion or collaboration among apps when your policies are only about individuals, yes, you will always run into that problem. I think, here's my speculation. I think in the physical world, you'll notice if something weird is happening, right? Like, I'm just imagining my robot picking up a microphone that I put in one place and it dropping it in another place so that it can now listen in to a space that it's not allowed to listen in on. I would probably find that pretty strange. And now, maybe, I don't know, I'm speculating, right? Maybe it hides it, and so then all bets are off. But I think part of what an operating system for physical AI would have to do is understand the locations of things. If it's going to regulate space, then it has to understand the locations of things. And if it can also monitor communication among devices, then maybe it can do something more intelligent than just saying, oh yeah, this thing is not allowed in this space, but it is talking to something that's in that space. And so something might be amiss. So I think with some more advanced understanding of communication patterns, maybe you can make some progress on this, but it would definitely be a problem if you did it on day zero in a naive way.
Okay, I just want to make a plug for some work you did in the past, which I think is, and the plug is sort of a challenge to the whole community as well. So one of the things that Landon did many, many years ago was this thing called Taintroid, which was basically went into the operating system and looked at how your privacy information was being picked up by multitude of applications and sent back to the developers. And so by doing that work, by showing that, he raised the awareness to the point where Google and Android had to do something about it, and they did. And so many of the things that we enjoy today are part of that. The reason I bring that up is was because it's sort of a challenge. As you do the physical AI and as you sort of build all these devices, I think beyond the actual design, the monitoring of these things can obviously lead to both papers as well as the right thing to do in terms of shaming the device manufacturers or the product manufacturers of what is happening with their devices.
Yeah.
And there is a slew of, your work is one of the works. There were other pieces of work that have happened in the same space that have actually done that. So we have to consider this very, very seriously, because it does actually have pretty long-term implications on society and things. So anyway, I just wanted to.
Yeah, no, it's exactly right.
Monitoring.
All right, so I want to ask you, given that you're the foremost expert in this room on AI privacy for physical AI, can you give a 2-minute layman explanation of why privacy is an issue in physical AI for a non-expert? Because all of us here kind of understand why privacy is important. But how would you explain it to a person who does not understand the issues with privacy? Because awareness was an important problem that needed to be solved so that public got interested in privacy and we got GDPR. So
Yeah.
what would be your 2-minute layman explanation of why privacy is important in physical AI?
Right, so I can start with audio, which is if you have a device that is recording all the time, there are sensitive conversations that you don't want banked into your AI memory storage. So, in the near future, if not already, every conversation you have with an AI will be banked, and then when it responds, it will draw from that bank to respond to you in public places and private places and all sorts of things. I think one of the dangers is you have a conversation with somebody, they say something sensitive, or you say something sensitive, it gets banked, and then the AI doesn't understand that it's sensitive, and it reemerges in some place that you don't want it to reemerge. So sort of the benign thing is I have a conversation with you about what I want to give my wife for her birthday. And then I have a conversation later on, and it sort of spits out the fact that, hey, you were talking about this in the past, right? So that's a benign version of this. There are probably other sensitive subjects that you might not want to bubble up at in opportune times. So I think that's the audio version of this. I think in the sort of more general purpose, where you're worried about physical space, there I think it's pretty clear, where you don't want something barging into your bedroom or barging into an argument you're having and recording and gathering information about those very private moments in your house. You want those to sort of remain with the people and not necessarily be digitized. So I think those are two examples of, those are two examples where I think it's important.
All right, thank you. So let's thank our speaker again. And we'll take a brief bio break, and we'll be back at 4:15 for the most exciting